My name is Kwigamba Vedaste. I'm instructor in Rwanda Polytechnic in machine tool workshop. So today we are going to talk about the milling machine technology. Previously you have seen how to operate lathe machine and shaper machine. So not only that kind of machine used in the manufacturing process, but also a milling machine for accomplishing the specific task. So now the milling machine is type of machine used to remove the material while cutting tool is rotating against fixed workpiece. So the milling machine is classified into three categories based on the axis of spindle. The first one is a vertical milling machine, second one horizontal milling machine, the third one universal milling machine. So the classification of milling machine is based on the axis of spindle because it is where the operator can access the spindle of the machine in setting procedure. That's why it is very important to classify the milling machine based on the axis of the spindle. So not only those classification, but also another classification based on the name of discover of the machine and the other theory based, but not important for the operator. That's why we introduce the classification of milling machine based on the axis of spindle. So while saying the vertical milling machine means that the axis of spindle is vertical to the milling machine table. While saying the horizontal milling machine means that the axis of spindle is parallel to the milling machine table. So then universal milling machine is where the machine have both axes, vertical and horizontal at the same time. While saying the classification of milling machine, we have to talk about the milling machine cutters classification. The milling machine cutters classification should be broadly classified into three important categories. This is called the plain milling cutters. So the plain milling cutters are used to produce a surface, a flat surface. That flat surface is parallel to the axis of the spindle of the machine. So second one, we have the face milling cutter. Means that is a kind of milling cutter which are used to produce a flat surface which are right angle to the milling axis spindle. The third one, we can say the foam milling cutters. The foam milling cutters is that type of cutters which are used to produce a foam surface. Means that the surface produced take the form of the cutters. This is called the foam milling cutters. And then we have also the angular milling cutters. It's a kind of milling cutters used to produce the angular surface. That angular surface depends on the angle of cutter teeth. This will be used to produce the angular surface. For example, in this block, this is the angular surface. This has been produced by a cutter which has these angles. So now, after the introduction of milling cutters, we have to talk about milling machine operation. So the milling machine operation are broadly classified into also four categories. The first one, plain milling operation. Second one, face milling operation. Third one, angular milling operation. Fourth one is the foam milling operation. While saying the plain milling operation, simply that is the surface have been produced by using the plain milling cutters. So the surface produced is parallel to the axis of the spindle. So the second one, the face milling operation, is where you can produce a flat surface. That flat surface is at right angle to the milling machine spindle axis. Then angular milling operation means that the angular cutters have been used to produce the angular surface. It means that the surface have been produced, it is at the angle of that cutter have been used. The form milling operation is an operation which can be operated for producing a form surface. That form surface have the same shape to the cutter have been used. So those are mainly milling operation categories. So to say milling machine categories is not saying only it is that operation to be done in that by this kind of machine. Not only those family of categories, but also sub-operation depends on the cutter size, the cutter shape, geometry, and the other type of milling cutter used. It depends on the structure of teeth, the shape, but have to be classified into those main categories we said before. Now I want to introduce how the milling machine is. The milling machine we have here is a universal milling machine, as we said before. We have the horizontal axis. This is the horizontal axis spindle and the vertical axis spindle. Means that this is the universal milling machine. If the machine have one horizontal axis, means it's a horizontal milling machine. If the machine have only the vertical axis spindle, means that the vertical milling machine. The machine you have here is vertical, is a universal milling machine. Then we can describe the many parts of milling machine we have here. So there is a head spindle of milling machine, vertical head spindle, and the horizontal head spindle, and also the milling machine table, and also the column. This vertical parts, casted part, is called the column. This is the horizontal overarm here to support these vertical spindles. And also here we have the screen for reading the measurement. So the milling machine can undergo three-dimensional motion depends on the milling machine table structure. Means that the machine can undergo the x-axis, and the machine can undergo the z-axis, and the machine can undergo y-axis. Means that three-dimensional axis motion is very important for milling machine so that the operator can handle each work have been tasked. So the other important accessories for milling we have here is the dividing head. The dividing head should be there for fixing the workpiece and also to divide them into a specified axis spindle needed is where you can manufacture the gears. Means that the space between one teeth to the next teeth comes from this dividing head mechanism while being used. So simply that here there is some kind of handles which have to be used. The first one is to control x-axis motion. The second one is to control z-axis motion. The third one is to control y-axis motion. So those hand wheel are used manual operated the machine, and while setting process is going to start, better to use those kind of handles. At these handles, we can see the micrometer. The micrometer here, those kind of micrometer are used to take the measurement. It's very important while machining because amount of material being removed have to be specified by those micrometer. Of course, inspecting the measurement by the vernier caliper and the other instrument used, but you have to also to use those kind of micrometer while take a depth of cut or to count a feed motion. So here we have a controller, a main controller here is used to control some kind of motion we have here. There is a rotation motion we have here comes from that up motors there, and the other rotation motion for this horizontal axis spindle, which comes from in front the motor, the electric motor there, and also we have another automation motors here for allowing the table to move automatically. So that's how you have those various buttons which can be operated by pushing and release. So we start the machine. They start the machine. Then we control upper motion, down motion in a Z axis. And also we can control the motion of Y and the X by using this button push. Then we engage this lever to put in automatic, means that the machine is moving. The machine is moving in a Y direction. That's why our screen is displaying in a Y axis. Means that the machine is moving automatically. There is no need to operate manual. That's why this hand wheel is rotating. Means that in the place of a man, in the place of operator operating this hand wheel, the machine is engaging automatically. So also we can see how the motion of axis can move automatically. That's why this screen is displaying x-axis. X-axis is varying the measurement units. While you want to change the direction of motion, you change the lever in the left direction. So there is a change of sign. Means that at the initial position, when you change the direction, the machine can change also the negative sign. It depends on the initial position have been set. So simply, everyone have found way how to use this milling machine table in 3-dimensional motion, and it can be controlled such manually or automatically. This is very important for operator, for milling machine operator. It's better to master all levers here, such as automatically or manual. So after mastering to handle the motion of this milling machine table, it's better also to master how to deal with this, the vertical milling axis. So here we have the lever for switching on and off and the neutral zone. The neutral zone is used while you want to change the gears. This is the control for changing the speed of motor. It's better to put the machine in neutral zone. So when the machine is off, it's better to put this arrow flash wheel direct to 0. Then you want to put the machine on. It's better to put the machine in 1. This is a digital indicator for switching on and off. Switching off is pressed by 0. Switching on is pressed by 1. The neutral zone is pressed by putting the cutter here, the image of cutter. So there is a table here, spindle speed, which is indicating the spindle speed. This is very important for operator. It's better to set the specific cutting speed depends on the work being done, depends on the machining parameters, factors. Here should be respected. There is a position of L and position of high. High means that high speed. L means that low speed. The low speed is into two ranges. There is one range and the second range. In high speed range, we have the first one range and the second one range. So there is a way of selecting high is where this arrow directing to or low. It depends on the operator to choose the speed have to be used based those factors of machining condition. So now, this is simply how you can set the speed of vertical milling machine. So there is another possibility of using the horizontal milling axis where you can use the speed selector in this site. There is a variation of speed here. You can change the speed accordingly by using these parts so that you can have the speed, the specific speed will be used as an output speed in the horizontal milling axis. Another parts, many parts have to be indicated here. This is the angle indication. Means that the machine can rotate at a certain angle. This possibility of this machine is used also to produce a certain flat surface while in production. It depends on the work, how it has been designed. This kind of angle also have to be used. It comes from 0 to 45 in the positive and 0 to 45 in the negative. This part also is very important. So there is another important accessories which have to be discussed with you. This is called the vertical elbow. It's used in the vertical milling machine while you want to produce a flat surface from a vertical milling machine. You have to use the vertical elbows or milling machine elbows, which will be inserted in this shape. Then you fix this elbow so that you can use as the milling cutter. So sometime we will see the elbow which is permanent with the cutter. Another time you can find the elbow which is separate with the cutter. This cutter should be removed. It is separate with the cutting teeth. This is a permanently milling elbow with the cutters. There is no separate. It depends on the factory has manufactured this kind of the elbows. So, and also we have the universal horizontal elbows, which is used for horizontal milling machine. It means that if you mount this horizontal milling elbow, is where you can fix the cutting tools or milling cutters, of course, while you are going to adopt this horizontal spindle axis. It's better, it's a must to use this kind of the milling standard elbows. So dear students, this is a general introduction for milling machine. So you remember how you have manufactured these parts from left machine. There is threading operation, turning operation, and step turning of this. So this kind of milling machine will help us to produce hexagonal head bolts. Do you see? This is the image of This is the image of bolts, but there is no head. The hexagonal head bolt is there to facilitate to fasten and to loosen the bolts while fixing. So the next task we have to practice here is to produce the hexagonal head bolts accordingly the design we have here. Of course, you have to respect the measurement of this hexagonal head bolt. Then we produce these bolts. So now, I can ask you some question. How can we have the 6 sides on this cylindrical part? So I think that is where dividing head should be intervened. The next task we have is where I start to explain where the mechanism of dividing head is where we will deduce the formula used as a simple indexing method. At your level, not only simple indexing method, but also another method. But at your level, we have to focus on the simple indexing method. So thank you. Welcome to the next task for producing hexagonal head bolts.